सचिन पुजेरी, सचिन पुजेरी, अभिनंदन, अभिनंदन,
Yes, sir.
ओके, अभिषेक, अभिषेक, अक्षता, अक्षता,
Present, sir. Present, sir.
राइट, ओके, आनंद, आनंद क्या बानी, अंजुम,
Present, sir.
राइट, बसवराज, बसवराज, बसवराज ऐनापुरे, बसवराज ऐनापुरे, भाग्यश्री मठ, भाग्यश्री, भक्ति,
Present, sir.
ओके, भारती, भारती, चेतन कुमार, चेतन कुमार, दीपक, दीपक, दिव्या, दिव्या, गट प्रथमेश शिवाजी, गट प्रथमेश शिवाजी, ज्योति,
Yes, sir.
ओके, किरण लिगाड़े, किरण लिगाड़े, लक्ष्मीकांत, लक्ष्मीकांत, मानतेश,
Yes, sir.
ओके, मोळे प्रेम, मोळे प्रेम, नागेश, नागेश, नंदीश,
Present, sir.
नंदीश,
Present.
ओके, पूजा पाटिल,
Present, sir.
ओके, प्रमोद कुमार, प्रमोद कुमार, जस्ट अ मिनट, प्रमोद कुमार, प्रमोद कुमार, प्रवीण, प्रवीण मखदूम, प्रियंका, प्रियंका, संध्या, संध्या, संतोष, संतोष, संतोष सोनार,
Present, sir.
ओके, शाहबाज,
Yes,
शाहबाज,
sir.
राइट,
Yes, sir.
ओके, शफिया, शफिया,
Present, sir.
ओके,
Present, sir.
राइट, श्रीधर, श्रीधर, सृष्टि,
Present, sir.
राइट, सिद्धार्थ वर्णेकर, सिद्धार्थ वर्णेकर, सिद्धार्थ पाटिल,
Present, sir.
ओके, सुप्रिया,
Present, sir.
right? Vandana, Vandana, Vasant, Vasant, Vedatta,
Present, sir.
right? Yogesh, Yogesh, Mahesh Dodmani,
Yes, sir.
okay. Balesh, Balesh, Taik Mohammed,
Yes, sir.
okay. Praveen Rathod, Praveen Rathod, mute your cell phones. All of you mute your cell phones. Praveen Rathod, Praveen Rathod is there? Abhishek Palekar,
Present, sir.
okay. Aishwarya,
Present, sir.
right? Amanullah, Amanullah, Bandodkar Tanay Mohandas, Bhaurav, Bhaurav, Shodhan,
Present, sir.
okay. Devanar Anil Kumar Shekappa, Devanar Anil Kumar Shekappa, Nand Kumar, Nand Kumar, Pramod Kesti, Pramod Kesti, Rohini Pavle,
Present, sir.
okay. Rohit Alwani,
Present, sir.
right? Shashidhar Gaudar, Shashidhar Gaudar, Sridhar Badiger,
Present, sir.
okay. Saish, Saish, Snehal, Snehal, Vaishnavi, Vaishnavi,
Present, sir.
okay. Karthik, Karthik Yam, right. Anybody else joined late? Anybody else joined
Yes,
late?
sir. Sir, Chetan.
Chetan Kumar. Okay. What's your roll number, Chetan?
Sir, 11.
11.
Yes, sir.
Okay, right. Anybody else?
Sir, roll number 20. Cream Mole, sir.
Okay, right. Anybody else? Okay. Okay, students, let's begin with the class. Are you able to see the screen, students?
Yes, sir.
Yes.
Okay. We discussed about program in yesterday's class, then about clear accumulator instruction, complement instruction, and we also discussed how to find the two's complement of a given number. And we were discussing about the rotate instructions. The first rotate instruction that we discussed was RLA, rotate left the accumulator, right? So this rotate left accumulator instruction, it works by rotating the bits left. Okay, so each bits are rotated left there, right? Okay, so this figure showed that how the bits shifted from the LSB to the MSB. So the LSB bit will be shifted to the next higher bit, then D1 bit to D2 bit, and so on. Okay, this is simple rotate instruction. Rotate left the accumulator, rotate left the contents of A register. Okay, then after that, next instruction is rotate left the accumulator. We discussed the operation of this. The function is rotates 8-bit content of the accumulator 1 bit to the left. None of the flags are affected. Next is rotate left accumulator through the carry. Rotate accumulator left through the carry. RLCA. Function of this instruction is rotates the 8-bit content of the register A, it is accumulator 1 bit to the left through the carry flag. Rotates the 8-bit content of the register A 1 bit to the left through the carry flag. So if we consider the figure here, right, now it is rotating through the carry flag. It's through the carry flag here. So this is bit D7. Then we have D6, D5, D4, D3, D2, D1, and D0. Okay. Here, let's assume some of the bits, right? Let us assume that the data is 1, 0, 1, 0, 0, 1, 0, 1, 0, 0. This is the data that we have here. Okay. Now this has to be rotated left through the carry. It has to be rotated left through the carry here, right? How to rotate it left through the carry? So let us assume carry is 1. Let us assume that carry is 1 here. Carry is 1. Okay. Then let us consider the bit pattern. Format is D7, D6, D5, D4, D3, D2, D1, D0. Okay. So this is the bit pattern that we have here. All right. Okay. Now I have to rotate this content, that is 100101000 left through the carry flag. Now if I have to rotate it left through the carry flag, So this whatever this D7 is there, that will be stored in carry first. Okay, D7 will be stored in the position of carry. So this D7 will come in the position of carry here. D7 will come in the position of carry. Okay, so what will be stored in the position of carry? D7 is 1. Okay, so 1 will be stored in the position of carry, and whatever this 1 is there in already which is in the carry, that this is the D7th bit. Okay, just I will highlight this. This is the D7th bit. This is a D7th bit. Then this is the which is already present carry. Already present carry. Okay, so this bit will be shifted to the D0. It will be shifted to the LSB. Right. So here this carry bit will be shifted to the D0. Fine. So here you will get this as 1. This is 1. D0 will be shifted to D1. D0 shifted to D1 means then will be shifted to D2. Zero here will be shifted to D. So D2 shifted to D3, that is this will be 1, this will be 1. Fine. Then D3 shifted left by 1 bit. Similarly, D3 shifted left by 1 bit. That is D4. D4 will be 0. D4 will be 0. D4 will be 0. Okay. Next, D4 bit will be shifted to D5. D4 bit will be shifted to D5. So this is D4 bit shifted to D5 here. Shifted to D5. Okay. So this is 1. This is 1. D5 shifted to D6. Left by 1 bit. So D5 shifted to D6. It is 0. It is 0. And D6 is shifted to D7. D6 is shifted to D7. Okay. So this is how it is shifted here. This is 0. Okay. So this is the pattern that we get here. Left through carry. Rotate left accumulator current through the carry flag. This is accumulator. This is nothing but it is accumulator here. This one. This is what I have drawn first. D7 to D0. This is the content of the A register or the accumulator. That is 10010100. Okay. Now carry I have assumed as 1 initially. Okay, you can assume the carry as 0. Can assume the carry as 0 first, and then you can shift the bits left by 1 bit. Okay, through the carry flag. Now how this shifting will take place? D7th bit will be stored in carry. D7th bit will be stored in carry, and whatever is the bit in carry, that will be stored in D0. Whatever is the bit in carry, that will be stored in D0. And each bit D0 will be, from D0 it will be shifted left by 1 bit. D0 to D1, D1 to D2, D2 to D3, D3 to D4, D4 to D5, D5 to D6, and finally D6 to D7. So at the end, this is the value that we are getting. This is, that is 0010, that is 2, then 1001. Okay. So 0010 is 2, then 1001 is 29H. 29H is the final value after rotating left through the carry flag. What was the initial value? 1001, then 849. 94 was the initial value in the A register, accumulator register. After rotating left through the carry flag, the value in A register is 90. How much? 0010. Sorry, 0010 is 2. Okay, then 1001 is 929. It is 29H. Right. So you all understood here how the rotate the left through carry takes place. Is it clear here? Rotate left through the carry flag. Simple rotate, what is the difference between simple rotate and this one? In simple rotate, what will happen here in the above figure, what is shown here? D7 is shifted to D0, and each bit from D0 is shifted left by 1 bit up till D7th bit. Okay, carry is not involved. Carry is not involved in the simple rotate instruction. Okay, but in the rotate left through the carry flag is involved. Carry flag is involved. Clear here? So this is how the rotate left through the carry flag takes place. Fine. So is this understood here? How the rotating takes place through the carry flag in RLCA instruction?
Yes, sir.
Clear? This concept is clear here?
Yes, sir.
Okay, fine. Description is the bits rotated out of A are rotated into carry. That is, it is rotated first into carry, and whatever is a bit in the carry is rotated into the opposite end of the A register. Bit 7 moves into the carry flag. The original state of the carry flag will be moved into bit 0 position. So whichever is the D7th bit, that will be stored in the carry flag, and whichever is the carry flag already present, that will be stored in D0 position, bit 0 position. The operation is illustrated like this, indicated like this. An, you can take n value from 0 to 6. N you can take from 0 to 6. So n if it is 0, A0, then n, this is 0 plus 1. A0 to A1 or D0 to
Sir,
any problem?
ಸರ್ ಅದು
Yes.
ಕ್ಯಾರಿ 0 ಇದ್ರೆ ಏನಾಗ್ತದೆ ಸರ್ ಲಾಸ್ಟ್
ಅದನ್ನು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ಲಿ
ಸ್ವಲ್ಪ ಕನ್ಫ್ಯೂಸ್ ಆಗ್ತೈತೆ ಸರ್.
ಹೌದಾ, ಅದೊಂದು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ಲಿ
ಹಾ ಸರ್, ಅದು D7 ವ್ಯಾಲ್ಯೂ 0 ಇದ್ದಾಗ 0 ಇದ್ದು ಕ್ಯಾರಿ ಕೂಡ 0 ಇದ್ರೆ ಏನ್ ಮಾಡ್ಬೇಕು ಸರ್?
ಹೇಳ್ತೇನ್ರಿ, ಒಂದ್ ನಿಮಿಷ ಹೇಳ್ತೇನೆ, ಒಂದ್ ನಿಮಿಷ. ಈಗ ನೋಡ್ರಿ, ಸಪೋಸ್ ಇಲ್ಲೇ ಕ್ಯಾರಿ ಐತಂತ ವಿಲ್ ಅಸ್ಯೂಮ್ ದಟ್ ದೇರ್ ಇಸ್ ಅ D7 bit is 0. Okay, so this is the original data. So here it is, let us say it is 0 here. Then carry also is 0 according to what example you are giving. Carry is also 0. So this is the initial carry. This is 0. Okay. So if D7 is a 0, then this D7th bit will be stored in carry. That is, what is the D7 bit now? It is 0. Yes or no? It is 0. So 0 will be stored in the position of carry. So here 0 will be stored in the position of carry. And whatever is the already, this is the shifted bit. I'll highlight this. Then this 0 which is already present in the carry, that will be stored in D0 position.
ಹಾ ಸರ್, ಹಾ ಸರ್.
ಅರ್ಥ ಆಗ್ತಿಲ್ರಿ?
ಅಂದ್ರೆ D7 ಕ್ಯಾರಿ ವ್ಯಾಲ್ಯೂ ಸೇಮ್ ಅಲ್ಲ ಸರ್?
ಹೌದ್ರಿ. ಸೊ D7th ಬಿಟ್ ಏನ್ ಬರ್ತೈತಲ್ರಿ, ಅದ ಬಿಟ್ ಕ್ಯಾರಿದಾಗ ಸ್ಟೋರ್ ಆಕೈತ್ರಿ.
ಸರಿ ಸರ್.
D7 0 ಇದ್ರ ಕ್ಯಾರಿ 0 ಸ್ಟೋರ್ ಆಕೈತ್ರಿ. D7 1 ಇದ್ರ ಕ್ಯಾರಿ 1 ಸ್ಟೋರ್ ಆಕೈತ್ರಿ.
ಹಾ ಸರ್.
ಗೊತ್ತಿಲ್ರಿ? ಆಮೇಲೆ ಆಲ್ರೆಡಿ ಕ್ಯಾರಿ ಏನ್ ಪ್ರೆಸೆಂಟ್ ಆಗತ್ತಲ್ರಿ, ಅದು D0 ದಾಗ ಸ್ಟೋರ್ ಆಕೈತ್ರಿ. ಫಸ್ಟ್ ಏನ್ ಕ್ಯಾರಿ ಪ್ರೆಸೆಂಟ್ ಆಗತ್ತಲ್ರಿ, ಒರಿಜಿನಲ್ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಕ್ಯಾರಿ, that will be stored in D0 always.
ಮತ್ತೆ ಸಿಂಪಲ್ ರೊಟೇಷನ್ ಕೂಡ ಹಂಗೆ ಆಗ್ತೈತಲ್ಲ ಸರ್ ಮತ್ತೆ?
ಹೌದ್ರಿ, ಇದು ಸಿಂಪಲ್ ರೇಟ್ ಅಲ್ರಿ. ಯಾಕಂದ್ರೆ ಕ್ಯಾರಿ 0 ತಗೊಂಡ್ರಲ್ಲ ನೀವು. ಕ್ಯಾರಿ ಯು ಟೇಕನ್ as 0, so it is as good as simple rotate instruction. ಹೌದಲ್ರಿ? ಈಗ ಯಾವಾಗ ಅದು ಚೇಂಜ್ ಆಕೈತೆ ಅಂತಂದ್ರಿ, ಕ್ಯಾರಿ 1 ಇದ್ದಾಗ ಚೇಂಜ್ ಆಕೈತ್ರಿ ಅದು. ಹೌದಲ್ರಿ? ಈಗ ನೋಡ್ರಿ, ಸಿಂಪಲ್ ರೊಟೇಟ್ ದಾಗ ಹೆಂಗ್ ರೊಟೇಟ್ ಮಾಡ್ತೀವಿ ನಾವು, ಈ D7 ಬಿಟ್ಟು D0 ದಾಗ ಬಂತ್ರಿ. ಸೊ ಇದು D7 ಇಲ್ಲಿ 0 ಬಂತ್ರಿ, ಈ 0 ಇಲ್ಲಿ ಬಂತು D0, ಅಂದ್ರೆ ಇಟ್ ಇಸ್ as good as simple rotate instruction. ಯಾವಾಗ ಅದು ಚೇಂಜ್ ಆಕೈತೆ ಅಂತಂದ್ರಿ, when carry is 1, then it will change. Following here. Okay. So if carry is 0, it is as good as simple rotate instruction. When it will change, only when the carry is 1, that time it will change. Clear here? ಅರ್ಥ ಆಗ್ತಿಲ್ಲ? ಇನ್ನೊಂದು ಸ್ವಲ್ಪ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ಲಿ ಮತ್ತೆ? ಅರ್ಥ ಆತಲ್ಲ ನಂದೀಶ್?
ಸರ್ ಅದ್ ಮತ್ತೆ D7 ಒಳಗ 1 ಇತ್ತಂದ್ರ D0 ಬಿಟ್ಟು 1 ಆಗುತ್ತರಿ.
ಇತ್ತಲ್ರಿ, ಈಗ ನೋಡ್ರಿ, D7 1 ಐತಂತ ಇಟ್ಕೊಳ್ಳೋಣ. Let us consider that D7 is 1. Okay. Now D7 is 1 means carry will be 1. Let us assume carry is 0 or 1 according to your this thing assumption. Shabaz.
ಹಾ ಸರ್.
You are assuming carry as 0 or 1?
Carry 1 sir.
Carry 1 ಐತ್ರಿ. Original value is carry of 1 is 1 according to you.
ಹಾ sir.
Okay. ಇದು 1 ತಗೊಳ್ಳೋಣ್ರಿ ಹಂಗಾರ. ಇದು 1 ತಗೊಳ್ಳೋಣ್ರಿ. So ಈ 1 ಏನಾತ್ರಿ, ಇಲ್ಲಿ ಬಂತೀಗ. ಇಲ್ಲಿ ಏನೈತ್ರಿ, 1 ಬರ್ತೈತ್ರಿ ಈಗ. ಹೌದ್ರಿ? ಈ 1 ಏನಾತ್ರಿ, ಇಲ್ಲಿ ಬಂತ್ರಿ, D0 ದಾಗ ಬಂತು. ಆಲ್ರೆಡಿ ಪ್ರೆಸೆಂಟ್, ಇದು ಒರಿಜಿನಲ್ ವ್ಯಾಲ್ಯೂ ರೀ. ಇದು ಒರಿಜಿನಲ್ ವ್ಯಾಲ್ಯೂ 1 ರೀ. ಇದೇನ್ ಬಂತ್ರಿ, ಇಲ್ಲಿ ಬಂತ್ರಿ, ಇದು D0 ಗೆ ಬಂತ್ರಿ. ಹೌದ್ರಿ? ಆಮೇಲೆ D0 ಲಿಂದ ಏನಾಕೈತ್ರಿ, ಒಂದೊಂದ್ ಬಿಟ್ಟು ಲೆಫ್ಟ್ ಶಿಫ್ಟ್ ಹಾಕೋತ ಹೋಗ್ತೈತ್ರಿ. ಅರ್ಥ ಆಗ್ತೈತಿ ಶಾಬಾಜ್?
ಹಾ ಸರ್, ಅರ್ಥ ಆತ್ರಿ.
ಮತ್ತೆ ಯಾರಿಗಾರ ಡೌಟ್ ಐತೇನ್ರಿ? Anybody else has any doubts here in the functioning of this rotate instruction?
ಸರ್, ರೊಟೇಟ್ ಲೆಫ್ಟ್ ಒಳಗ್ ಕ್ಯಾರಿ ಮೆನ್ಷನ್ ಮಾಡ್ತಾರಲ್ರಿ?
ಹೌದೌದೌದ್ರಿ. ರೊಟೇಟ್ ಲೆಫ್ಟ್ ಥ್ರೂ ಕ್ಯಾರಿ ಒಳಗ ಕ್ಯಾರಿ ಮೆನ್ಷನ್ ಮಾಡ್ತಾರಂದ್ರೆ ಹೆಂಗ್ರಿ, ಕ್ಯಾರಿ ಅದನ್ನ ಕೊಡ್ತಾರ ಅವ್ರ. ಏನಾರ ಸಪೋಸ್ ನಿಮಗೆ ಅನಲೈಸ್ ಮಾಡಕ್ ಕೊಟ್ರ ಅಂತ ಇಟ್ಕೊಳ್ಳೋಣ್ರಿ. ಜಸ್ಟ್ ಲೆಟ್ ಅಸ್ ಕನ್ಸಿಡರ್ ದಟ್ ದೇ ಹಾವ್ ಗಿವನ್ ಸಮ್ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ಸ್ ಟು ಅನಲೈಸ್. Okay,
ಹೌದು
what is
sir.
the content of the accumulator after rotate instruction? Then they have to give the carry. They have to give the carry.
ಎಸ್ ಸರ್, ಕ್ಯಾರಿ ಕೊಟ್ರ ಅಂತಂದ್ರ ಅದ ರೊಟೇಟ್ ಲೆಫ್ಟ್ ವಿತ್ ಕ್ಯಾರಿ ಅಂತ ಅಂದಂಗನರಿ ಸರ್.
ಹೌದ್ರಿ, ಕರೆಕ್ಟ್, ಯು ಆರ್ ರೈಟ್, ಎಕ್ಸಾಕ್ಟ್ಲಿ ರೈಟ್.
ಓಕೆ ಸರ್, ಓಕೆ ಸರ್, ಥ್ಯಾಂಕ್ ಯು ಸರ್.
ಓಕೆ, ಅದ ಕ್ಯಾರಿ ಕೊಟ್ರ ಅಂತಂದ್ರ ಅದ ಕ್ಯಾರಿ ಥ್ರೂ ಯೂಸ್ ಮಾಡಿ ಮಾಡ್ಬೇಕಂತ ಮೀನಿಂಗ್ ಇರೋದು. ಕ್ಯಾರಿ ಕೊಡ್ಲಿಲ್ಲ ಅಂತಂದ್ರ ಸಿಂಪಲ್ ರೊಟೇಟ್ ಇನ್ಸ್ಟ್ರಕ್ಷನ್.
ಎಸ್ ಸರ್, ಎಸ್ ಸರ್.
Fine. Okay. Anybody else has any doubts here? Followed, right? Okay. Let us move on with the next instruction. So carry will be stored in A0 and A7 will be stored in the carry. None of the flags, that is, carry flag is affected with the RLC A instruction because it is rotate through the carry flag. So carry flag is affected with the RLC A instruction. Next, rotate accumulator right. Rotate right the accumulator content. This rotates the 8-bit content of the A register 1 bit to the right. The bits which are rotated back into accumulator at the opposite end. In case of RLA also it is rotating to the opposite end. Here also it is rotating to the opposite end. But in RL it is rotating left by 1 bit. In RR it is rotating right by 1 bit. Rotate left RL, rotate right RR. Okay, the bits rotated out of A are rotated back into A at the opposite end. What it means, bit 0 is rotated into the bit 7 position. In RLA what happens? Bit 7 is rotated into bit 0 position. Here it is opposite. In RRA, bit 0 is rotated into the bit 7 position. Okay, let us consider one example here. So this is rotate left. Let us see rotate right. We have D7, D6, D5, D4, D3, D2, D1, D0. Let us assume some bits here. Let us consider 1, 0, 1, 0, 1, 0, 1, 0. And this as 0, 1, 0, 1, 1, 0. Okay. Now let us find out how it will rotate. Sorry. And this is a D7, then D6, D5, D4, D3, D2, D1, D0. Now rotate right. Rotate right means how it will rotate. Rotate left means D0 will be stored in D7 position. Okay. D7 will be stored in D0 position in rotate left. Okay. Then each bit will be shifted left by 1 bit. D7 to D0. Okay. In rotate right means D0 will be stored in D7 position and each bit will be shifted right by 1 bit. Let us consider the figure, then you will understand that. So here D0 will be shifted to D7. D0 will be shifted to D7. Okay. Then this is D0 is 0. That means D7 is also 0. D7 is also 0. Then D7 each bit is shifted right by 1 bit. So it will go on rotating, shifting by 1 bit. D7 will be stored in D6. D7 will be stored in D6. Then this is D6 stored in D5. Then we have D5 stored in D4. Next, D4 stored in D3. D4 stored in D3. Then we have D3 stored in D2. D3 stored in D2. Then D2 stored in D1. D2 stored in D1. Okay. Then finally D1 will be stored in D0. Right. Let us find out the values here. D7 to D6. So it is 1 here. D6 to D5. It is 0 here. D6 value has come into D5. D5 value will come into D4. This is 1. D4 value will come into D3. That is 0. D3 value will come into D2. That is 0. D1 value, D2 value will come into D1. That is 1. D1 value will come into D0. That is 1. This is how the rotating right takes place. See the rotate left. Okay. So here it is D0 to D7. D0 to D7. What about in rotate left? D7 to D0. You can see the arrow mark here. Arrowhead is pointing from D7 to D0. It is opposite to RRA and RLA. Both are opposite. Okay. In RLA, it will be from D7 to D0. Then each bits are shifted left by 1 bit. In RRA, it will be the opposite. That is from D0 to D7. Then each bit from D7 will be shifted right by 1 bit up till the D0 bit. Clear here? So what is the initial value? 1010. It is A0110, A6. Then what we get after the rotate instruction? This is 0101, that is 5, 0011, that is 3. So 53H is the value in A register after rotate write the value in A register. This is without the carry flag. This is without using the carry flag. Okay. So this concept is clear here, students. Rotate accumulator right. Anybody not understood
sir.
this? Clear, right? Okay.
Yes, sir.
Okay, fine. So rotates the 8-bit content of the register A 1 bit to the right. Then we have operation of this AN plus 1. How to indicate the operation of this? N is 0. Let us start with 0 first. So 0 plus 1, that is A1. A1 will be stored in A0. N is 0. Next, if we take N as 1, 1 plus 1, A2. A2 will be stored in A1. Okay, rotating right. Right. Then if we take A2, N is 2. 2 plus 1, 3. 3 to 2. N is 2. So 3 will be shifted to D3 bit will be shifted to D2. Then if we take N equal to 4. 4 plus 1, 5. D5 will be shifted to D4 like that. So each bit is shifted right by 1 bit. Then A0 to A7. A0 to A7. This is the one which indicates the how the rotate right the accumulator operation takes place. So here none of the flags are affected because carry is not involved. So carry flag is not affected by the RRA instruction. Next, rotate accumulator right through the carry. RRCA, rotate accumulator right through the carry. So this rotates the 8-bit content of register A, is accumulator 1 bit to the right through the carry flag. This rotates the 8-bit content of A register through the carry flag by 1 bit. So the bits rotated out of A are rotated into the carry, and the carry is rotated into the opposite end of the accumulator. What it indicates, bit 0 moves into the carry flag. This is opposite to RLCA instruction. In RLCA instruction, what happens? Bit D7 will move into carry and carry will move into D0. Here it is opposite. Bit D0 will move into carry and carry flag which is already present, that will move into D7. Bit 0 moves into the carry flag. Original state of the carry flag moves into the bit 7 position. Right. Let us take one example here to see how this works. D7, D6, D5, D4, D3, D2, D1, D0. Consider the values 1, 0, 0, 1, next 0, 1, 1, 0. Then next we'll consider the rotating operation. D7, D6, D5, D4, D3, D2, D1, D0. Okay. So here we have to consider the carry, is it not? We have to consider the carry here. So let us assume the value of carry. What carry shall we assume? 0 or 1? We'll assume 1. Because 1 is slightly different from what is 0. 0 means it is simple rotate instruction, rotate right. Okay. So if carry is 1, then it will change. Let us assume it as 1. If it is 1, then how the rotate right through carry flag works? So what will be stored here? So D naught will be stored in the position of carry. So D naught will come here. This D naught will be stored in the position of carry here. D naught will be stored in the position of carry. Okay. So what will be stored here in D naught? D naught 0 will be stored. D naught value will be stored in the position of carry, that is 0. And the one which is already present as a carry flag, that will be stored in D7. This one will be stored in D7. That we will indicate here. This one will be stored in D7. Okay, it is rotating right side. Okay, so this is one will be stored here. So this is 1. Okay, so this is 1. Then each bit will be shifted right by 1 bit. Each bit will be shifted right by 1 bit. So this is D7 to D6, D7 to D6. Then we have D6 to D5, D6 to D5. Then next D5 to D4, D5 to D4. Okay, then next is D4 to D3, D4 to D3, D4 to D3. Then next D3 to D2, D2, D3 to D2 here. Next D2 to D1, D2 to D1. Okay, D2 to D1. D2 to D1 here. Okay, then D1 to D0, D1 to D0. Okay, D1 to D0. So this D7 is shifted to D6, it is 1. D6 to D5, it is 0. Then D5 to D4, it is 0. D4 bit is stored in D3, it is 1. And D3 bit is stored in D2, it is 0. D2 bit is stored in D1, it is 1. And D1 bit is stored in D0, it is 1. So this is how the shifting has taken place. Rotate right to the carry. So this is which instruction? RRC A. RRC A. What is the initial value we had taken in A register? So initial value that we had taken in A register is how much? 1001, that is 9. 0110, that is 6. So 96H was the initial value. After rotating right through the carry flag, the value in A register is how much? Let us check. Is equal to 1100. It is 12. 12 means C. C hexadecimal 1011. It is 11. 11 means B. After A, it is B. So CBH is the value in A register after rotating right through the carry flag. Okay. So this is how the rotate right through the carry flag takes place. Is it understood here, students? How the RRCA instruction works? Is it clear here?
Yes, sir.
Okay.
Yes, sir.
Fine. Next. So that is what it is indicated here. AN to AN minus 1. That is, suppose let us take AN as 1 first. So 1 bit, that is A1 is shifted to 1 minus 1, 0. Okay, it is rotate right. So A1 to A0. Then if we take N as 2, A2 to A1, A3 to A2, A4 to A3. So it is rotating right by 1 bit to the right side. Okay, then carry bit will be stored in A7, A0 bit will be stored in carry. Carry bit will be stored in A7 position or D7 position, and D0 bit will be stored in carry, or A0 bit will be stored in carry. Which flags are affected here? Carry flag is affected. CY flag is affected with the RRCA instruction. Right. Next is swap instruction. Swap A, swap the contents of accumulator. Swap the contents of A register. Swap A, it is 1 byte instruction. It takes 1 machine cycle to execute. Right. Then what is the function of swap A instruction? Let us take an example here. Swap A. swap A. Let us consider the initial value in A register as A value is, let us say it is 43H, 43H. After swapping, the value in A register will be, in swap A instruction, the upper and lower nibbles are interchanged, they are exchanged, which is the upper 4 bits 4. Okay, so this will be stored in the position of lower 4 bits, that is in the lower digit position higher digit will be stored, and in the higher digit position lower digit will be stored, that is 3 will be stored.
3, 4,
So
sir.
this is the function of swap A instruction. Swap A means the higher digit and the lower digit of the value in A register are exchanged. Okay, or the upper nibble and the lower nibble of the A register are exchanged. So if it is 43H, it will become 34H. If it is 78H, it will become 87H, like that. Okay. So here the only operand is A register. That is, you can store the value, you can swap it only if the value is stored in A register. You cannot swap in the other registers. So the value must be present in A register, then only you can swap the value. So if you want to swap the values, you have to bring that particular value, whichever you want to swap in A register, and then only you can swap it. Okay. You cannot swap it using any other registers. It is possible only with the A register.
ಸರ್ ಸರ್
Yes, please. Yes.
ಸರ್ ಸರ್ ಎರಡು
Here,
ರೆಜಿಸ್ಟರ್ ಆಗಿರೋ ವ್ಯಾಲ್ಯೂ ಸ್ವಾಪ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ಏನ್ ಮಾಡ್ಬೇಕು ಸರ್? ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಎ ರಿಜಿಸ್ಟರ್ ಆಗಿದ್ದು ಬಿ ರಿಜಿಸ್ಟರ್ ಆಗಿ ಬರ್ಬೇಕಂತ.
A register ಇದ್ದದ್ದು value ರೀ B ದಾಗ ಬರ್ಬೇಕಾ?
ಹಾ ಸರ್.
Okay. So let us say A register is there. So this you want to A register, let us say it is say 43H. This you want to swap with some other register, say it is having the value 57H. Okay. So if you want to swap it 43H with 57H. Okay. Now here we have to write a small program for this. See 43H, if you are swapping, you will get 34. Okay. There is no instruction to swap the values between two registers. Remember that. There is no instruction which can directly swap the values between two registers. No, it is not possible. We have to write a small program for this, which will help us to find out the exchange of 43 with 57. Okay, like what I have to do, first I have to separate this 4 and 3. 4 and 3 I have to separate it out. This 4 I have to make it 04 and this 3 I have to make it 03. So it is called as unpacking. This particular number is called as packed number. Packed number means higher digit is also present, lower digit is also present. It is called as packed number. Okay. Now if you are separating 04 and 03, suppose if we make them as 04 and one more number as 03, this is called as unpacking. Unpacking. Okay. Packing means both higher digit and lower digit are present. It is called as packing. Unpacking means we are separating the higher digit and the lower digit. It is called as unpacking. So we have to separate them out. Okay, once we separate them out, then you can see that you have to separate this 05, right? And then here also 07. You have to separate them out and then you have to exchange them. You have to write a small program for this, right? Wherein you can exchange, first you have to unpack them. So once if you unpack them, right, this 43 has to come in the position of 57. So then you have to use some move instructions, right? So you have to use a move instruction so that now say 43H is there in A. Okay. So let us say we are moving that. Move R5, comma, move R5. First let us take A value as A, comma, hash 43H. A, comma, hash 43H. Okay. Then next I am moving this value from A to some other register. Move R5, comma, R5, comma, A. Okay. So I have moved the value in register to R5. R5 is equal to how much? That is 43H. A is equal to 43H. Right. Now value in A is I have stored in R5. Okay. Next move, I will use A, comma, hash 57H. 57H. Right. Then what I will do next, move move R6, R6, move R6, right? Move R6, that is value in A. Okay. So this is R6 is equal to value in A, that is 57H, 57H, right? Next, so we got one value in R5, another value in R6. Now what I will do, I will use move. This is there in A is 43H. Let us take this A. Then I will use the instruction move A, move A, move A here, move R5, A. So in A we R5 we got 43H. Okay. Then in R6 we have 57H. R6 we have 57H. Okay. Now this 43H, if I take it in say R5 is 43H. Then we have R6 is equal to 57H. R6 is equal to 57H. Right. Now what I will do, move A, R5, move A, that is move A, that A R5 value should be for 57, right? So R5 value should be 57. So first I will get that value from R6, move A, R6. Then what I will do, move. So I got the value in R6. A is how much? 57. Okay. So A is 57H. From here I have to move to R5. Okay. So move R5, A. Move R5, A. So this value in R6 has come to R5. Okay. Next, once it has come to R5, that is R5 is equal to how much here? R5 is equal to value in A. Value in A is 57. So 57H has come here. Okay. Then next, so value it was in R5, that now that value has come as 57. Now I have to move the value, other value, that is R6. Okay, R6 value should be 43H now. Correct. So now if I want to move that value, okay, so first bring it to A register, move. We brought A value, right? Then here we require one more intermediate register here, dummy register. Okay, so yes, R0, if we have R2, R2 is equal to. So what we have to do is here, if you want to exchange these two, we have to have one dummy register. Okay, so what this R5 value, first we have to bring it into 43H, that is R2. Okay, then R6 value we have to store in R5. R6 value we have to store in R5. R5 is equal to R6. R5 is equal to R6. So what we get here, R5 is equal to R6, that will be 57. Okay. Then what we have to do next, using the move instructions, we have to store the value which is there in, now R2 we have 43H, right? That is the value in R5. So now R2 value I have to move in R6. So R6 is equal to R6 is equal to R2, that is equal to R6 is equal to R2, that is equal to 43H. Now what value we got here, students? R5 value we are using on dummy register here, as we are doing in C language, a temporary variable. Like we have to use a dummy register here, right? So R5 value you store it in dummy register R2, right? You got it as R6 is equal to R2, that is equal to 43H. Okay, store that R5 value in R2, then store R6 value, this value, R6 value whatever is there, this you store it in this. Now R5 is empty, you already moved it into R2. So R6 value you store it in R5. Okay, so R6 is equal to R5, that is equal to 57H. Then this R6 is empty. So R6 is empty, as good as empty. Then R2 value, which is nothing but R5 value, that you store in R6. So like this we have to interchange. Nandish, is it understood here?
Yes, sir.
Nandish? Huh?
ಹಾ ಸರ್
Understood,
ಎಸ್
right?
ಸರ್
ಸರ್
Like how
Sir,
you are
ಇಲ್ಲಾಂದ್ರ-
doing in C language using temporary variable. Okay, you are using a dummy register, dummy variable, right? In C language. Yes or no? Nandish?
ಸರ್
Nandish?
ಎಸ್ ಸರ್
Similarly, you have to use a dummy register here, dummy variable, and using the move instruction, just now what I told, you have to use them and you have to extend them.
ಎಸ್ ಸರ್
Clear here? Huh?
ಎಸ್ ಸರ್
Okay, fine. Any other questions here?
ಸರ್ ಇದು XCH ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ಯೂಸ್ ಮಾಡಿ ಇದ್ ಮಾಡ್ಬೋದಲ್ಲ ಸರ್ ಈ ಪ್ರೋಗ್ರಾಮ್ ಬದಲಿ
XCHD ಒಳಗೆ ಏನಾಕೈತ್ರಿ ಓನ್ಲಿ ಲೋವರ್ ನಿಬಲ್ಸ್ ಎಕ್ಸ್ಚೇಂಜ್ ಆಗ್ತಾವ್ರಿ ಮಾಂತೇಶ್.
ಸರ್ ಅಲ್ರಿ XCHD
ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ XCHD ಒಂದ್ ಹೇಳ್ತೀನಿ ನಿಮ್ಗೆ.
ಸರ್ ಡಿ ಅಲ್ರಿ XCH ಅಷ್ಟೇ ರೀ.
ಏನಂದ್ರಿ ಮಾಂತೇಶ್?
XCH ಅಷ್ಟೇ ರೀ ಸರ್. ಬೈಟ್ಸ್ ಎಕ್ಸ್ಚೇಂಜ್ ಆಕವ್ರ ರೀ.
ಎಕ್ಸ್ಚೇಂಜ್ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ನೋಡಿ ಹೇಳ್ತೀನಿ, ಸ್ವಲ್ಪ ನೋಡಿ ಹೇಳ್ತೀನಿ. ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ ನೋಡಿ ಹೇಳ್ತೀನಿ. XCHD we have come across now. XCHD we have come across, right? This will exchange only the lower nibble with the lower nibble.
Yes sir. And XCH will
ಮುಂದಿನ ಕ್ಲಾಸ್ ಸ್ವಲ್ಪ ನೋಡಿ ಹೇಳ್ತೀನಿ.
Yes sir, okay.
XCH ಬೇಕಲ್ಲ ನಿಮಗೆ? XCH
ಡೈರೆಕ್ಟ್ ಎಕ್ಸ್ಚೇಂಜ್ ಆಕವ್ರಲ್ಲ ಸರ್.
ನೋಡ್ತೇನೆ, ಸ್ವಲ್ಪ ನೋಡಿ ಹೇಳ್ತೇನೆ.
Yes sir, okay.
Okay. Any other questions here? Any other questions? Clear, right? Today's topics, what all we discussed, is it understood? So today we discussed rotate RLCA, rotate accumulator left through carry, rotate right the accumulator carry, RRA, then RRCA, rotate accumulator right through carry. Okay. Then swap A, swap the contents of accumulator. Fine. So in the next class, we'll be taking up the program branching instructions, absolute call, okay, then L call, right? Then other call and jump instructions that we'll take up in the next class, right? Any other thing you want to discuss here? Clear, right? Today's topics understood, everyone? Today's topics you all understood?
ಎಸ್ ಸರ್
Okay, fine then. Okay.
Yes, sir.
Okay, thank you.